Alright, here are our solutions for perfect problem 6 for Math 251. We're given this absurd mess of a function and asked to find its derivative. And you could do it, it just wouldn't be fun. It'd be chain rule and product rule and product rule and chain rule and quotient rule and product rule and product rule and just be a huge mess of rules nested inside each other. You could do it, but it would take forever. So there's a trick, and essentially the trick is using this thing called logarithmic differentiation. And the idea there is instead of f of x equals all this stuff, we make it y equals all this stuff, so that I can then take the natural log of both sides of the equation and get that the natural log of y is equal to the natural log of all this stuff. And all this stuff is a mess, but maybe I can write it in a form that'll make it a little bit easier to deal with. So the first thing is, it's the natural log of a bunch of stuff, and I'm taking the 49th root of all that stuff. Taking the 49th root of something is the same as raising something up to the 49th power. And what am I taking the 49th root of? Well, let's see, up in the top, it's the cubed root of a bunch of stuff. So that means all the stuff up top is getting raised to the 1/3 power. And what specifically? Well, 2 to the x power times x to the 2x power times sine of x raised up to the 4th power. This is the same as this. I think this is an easier way to write it. Times a quotient, sure, x e to the x power divided by x to the 1/2 power. And all of that is divided by this mess down here, specifically x times, it looks like the square root of, so a bunch of stuff raised up to the 1/2 power, that stuff being 5x squared times, no, this one's kind of weird, the 3x root of x plus 1. In other words, x plus 1 raised up to some power. Turns out that power is 1 divided by 3x. Where that comes from is kind of the same idea. The reason the 49th root is equivalent to raising something to the 1/49th power is the same reason that taking the 3x root of something is the same as raising it up to the 1/3x power. Alright, still a little bit impossible to look at. But what we can do is we can apply a bunch of different log rules. So we have 3 different log rules. Maybe I'll write these out here. We know that the log of a product, a times b, is equal to the sum of those 2 logs. We know that the log of a quotient is equal to the difference between those 2 logs. And then we know, and finally we know that the log of a power is equal to whatever that power is times the log of whatever the base is. Using these 3 rules, we'll be able to rewrite this mess in a way that we can take the derivative. And so the first thing to note is, using this 3rd rule, I'm taking the log of a bunch of stuff raised up to the 1/49th power. So what that means is I can call this 1/49th times the natural log of a bunch of stuff. Okay, what do I do? How about this? Natural log of all that stuff. Cheating a little bit, but fine. I'm the teacher, I'm allowed to cheat. Natural log of stuff, all of this stuff inside of the parentheses, can also be simplified. And the way you'll do that is, well, it's something divided by something else. So the natural log of something divided by something else is the natural log of the top. I should have done this stuff thing here. I was just being lazy. I'm going to copy it. The natural log of 2 to the x times x to the 2x times sine of x raised up to the 4th power times x times e to the x divided by x to the 1/2 to the 1/3, all divided by x times 5x squared times x plus 1 raised up to the 1/3x power, and all of that to the 1/2 power. natural log of all that stuff. Well, what I now have is the natural log of a quotient. Here's the top, here's the bottom. So I can rewrite that as 1/49 times the natural log of the top, 2 to the x times x to the 2x times sine of x to the 4th power times x e to the x over x to the 1/2 to the 1/3 power minus the natural log of everything that's down on the bottom, x times 5x squared times x plus 1 to the 1 over 3x power raised to the 1/2 power. So let's see, that closes that one, that closes that one, and that's closed there. All right, what a mess. Fortunately, this one simplifies a lot in this next step. Well, I guess I should do one more step. I got some exponents here. I got a bunch of stuff raised up to the 1/3 power, right? So I have 1/49 times 1/3 natural log of all this stuff, 2 to the x times x to the 2x times sine of x to the 4th times x e to the x over x to the 1/2. 1/3 times the natural log of all that stuff minus the natural log of x times some stuff. Well, let's see, the natural log of x times some stuff using that first log rule is the same as the natural log of x plus the natural log of that stuff. And so what I have is the natural log of all of this raised up to this power. So I can say plus 1/2 times the natural log of 5x squared times x plus 1 to the 1 over 3x power. Get to there. Parentheses. Look good. Okay, still haven't done any calculus. Someday we'll be able to. 1 over 49 times 1/3 times the natural log of the product of a lot of different things is just the natural logs, the sum of all those different natural logs. So what I'm saying is I got the natural log of 2 to the x plus the natural log of x raised up to the 2x power plus the natural log. How about I could bring that 4 down in front and say plus 4 times, I'll do that in the next step, plus the natural log of sine of x raised up to the 4th power, and then plus this quotient. So the natural log of x e to the x minus the natural log of x to the 1/2 power. And this parenthesis is closing this parenthesis, which is good. But then I still need to subtract all this stuff. So I got minus natural log of x plus 1/2. The natural log of is a product of two things. So it's the natural log of the first thing plus the natural log of the second thing. I'm out of room. That's good because I was done with that line anyways. Finally, one more time around, and I think I'll be able to be done with all of these. 1 over 49 times 1 over 3 times the natural log of 2 raised up to the x power. You can bring that x down in front and call it x times the natural log of 2. Plus natural log of x raised up to the 2x power. You can bring that 2x down in front and call it 2x times the natural log of x. Plus, I got a 4 up in the exponent. Bring that down in front. Natural log of sine of x. Here I got the natural log of x times e to the x, which is the same as the natural log of x plus the natural log of e to the x, which is just 1. Should I show more steps there? Probably. 1 is the same as the natural log of e to the x. I split this up into 2 using a log rule. And then from that, I want to subtract the natural log of x to the 1/2 power. I can bring that 1/2 down in front and call it the natural log of x. So I want 1/3 times all of this stuff, and then I want 1/49th. See, I close those right? Yeah. 1/49th of all this stuff minus all of this stuff. And all of this stuff is the natural log of x plus 1/2 times the natural log of 5x squared. Make sure I got this right. Where the hell did that come from? Up here, 5x squared. Okay, so the natural log of 5x squared, I can think about it as it's the natural log of 5 plus the natural log of x squared. But the natural log of x squared is just 2 times the natural log of x. So that's this part. And then to that I want to add the natural log of x plus 1 raised up to the 1 over 3x power. Well, I can take that 1 over 3x down in front and multiply that by the natural log of x plus 1. Close those parentheses, close those parentheses, close those parentheses, and then close those parentheses. Probably missing some closed parentheses up here. Okay. We haven't done any calculus yet. We've just rewritten this problem 100 times. We can now do some calculus. Take the derivative of both sides of the equation. On the left, we'll get 1 over y prime. On the right, I'll get, well, this is a constant times something. Pull that constant out in front. Something. What is that something? Well, I got a constant times something. Pull that out in front. The derivative of x times the natural log of 2. Natural log of 2 is just a constant. Derivative of x is 1. So I get the natural log of 2. Plus 2x times the natural log of x. I'd have to use the product rule here. The derivative of 2x is just 2. Multiply that times the natural log of x. Plus the derivative of natural log of x is 1 over x. So 1 over x times 2x. How about 2x divided by x? Doesn't that simplify to 2? Yeah, it does. Do that in the next step. Maybe I'll say that this was product rule. So that was this guy. And then I need the derivative of 4 times the natural log of sine of x. Well, if 4 is just a constant, leave it alone. The derivative of natural log of sine of x, I have to use the chain rule. The derivative of the outside function is 1 over the inside function, which is sine of x. And then the derivative of sine of x is cosine of x. So it's chain rule going on there. And then plus natural log of x, just 1 over x. The derivative of 1 is just 0. Minus 1/2 times the derivative of natural log of x, which is 1 over x. Close those parentheses, subtract. The derivative of natural log of x is just 1 over x, and that's not an x. And then to that I want to add 1/2 times the derivative of natural log of 5, that's just a constant, its derivative is 0. Plus 2 times the derivative of natural log of x, 2 is a constant, derivative of natural log of x is 1 over x. Plus 1 over 3x times the natural log of x plus 1. I'm going to have to use the product rule there. I can think about 1 over 3x as 3x raised up to the negative 1 power. The derivative of 3x raised up to the negative 1 power, maybe I'll do it this way, is negative 1 times 3x raised up to the negative 2 power. So that's f prime. And then my g is natural log of x plus 1. And then to that I want to add g prime, the derivative of natural log of x plus 1, which is 1 over x plus 1, times f 1 over 3x. Get this mess here. And I guess I should say that this was product, and then this was chain. Okay, so finally, well, I guess I should simplify this. Maybe I can do it in one step. Y prime, if I multiply both sides of the equation by y, is equal to y times 1 over 49. How about y over 49? Hey, that'll simplify a little. Well, no. Y times 1 over 49 times 1 over 3 times natural log of 2 plus 2 natural log of x plus 2 plus 4 times cosine divided by sine. In other words, 4 cotangent of x plus 1 over x minus 1 over 2x. Could put those together, but I'm not going to bother. Minus 1 over x minus 1/2 times a bunch of stuff. And that stuff is 2 over x minus natural log of x plus 1 divided by 3x squared, that's this thing, plus 1 over 3x times x plus 1, this thing here. Oh man, what a mess. Alright, well, gone this far. So finally, y prime equals y, which is all of this stuff, times all of this stuff above. Cheating a little bit, fine, because y is just equal to all of that stuff. Alright, what a mess. Sorry for making you do this. I guess I'll end this video here.